It's time to implement the last bit of hardware for the load, the temperature monitoring section. I gave myself plenty of headers for the temperature sensors, supporting both analog and digital sensors. But now that I can detect whether the fans are running, I simply need the temperature of the MOSFETs. I can't see any need to know what the temperature of the heatsink fins are. Now, to determine where to put the sensors for each of the MOSFETs, I decided to do a bit of temperature probing just to see what's what. I turned the load on with enough power to get the MOSFET mounting surface into the 50 to 60 degrees centigrade range, basically about the limit of what I want it to run at. Right now, no fans are running on the heatsinks, so there's barely any air movement over the heatsinks other than what the ceiling fan in the room moves. As would kind of be expected, the hottest location seems to be right beside the lower part of the MOSFET case. This is as close to the die as I can get without getting under the MOSFET, and I'm not about to try that again, not with these heatsinks. And there really is no need to. I only have about 2.5 degrees C difference between the hottest spot and the very corner of the heatsink base, which seemed to be about the coolest. 40 to 50 watts going through the MOSFET here. So if I use the data sheet's 0.3 degrees C per watt junction to sink value, at 50 watts that would put the junction temperature 15 degrees higher than what I'm measuring at the heatsink. So if my measurement point varies a couple of degrees from the temperature right under the MOSFET, practically it's not going to make that much of a difference. I did find up to a 5 to 6 degrees C difference on the easy to get to heat pipe. I was considering attaching the temperature sensor to the heat pipe, but I felt that was just too much temperature difference. I would like to get the temperature sensor close to the MOSFET. Of course, the closer the better. But how to mount the sensor close to the MOSFET, preferably without redoing the entire mounting bracket? I'm going to try some thermally conductive tape here and see how it affects my temperature readings. I'm going to use a wooden stick to hold the thermocouple to the tape, so it's not a lot of heat load on the sensor. So mounting with the tape cost me what? A degree or degree and a half? And I would expect most of that is from the large piece of tape I used, and the fact I'm further away from the MOSFET. But this is where the sensor would have to mount, and I think that will work pretty good. Before I order a flexible PC board, I want to do a test and see if mounting the temperature sensor beside the MOSFET is going to work. It turns out this FFC's traces have about the same pitch as the pins of an SOT23 package, which is one of the packages I have the temperature sensors in. So I'm going to cut me a 3-trace section and give it a try. I'm going to scrape a bit of the plastic off. The only thing is, the plastic is a very low temperature plastic. It will just melt away when hit with the soldering iron. So I'm going to back up the FFC with some Kapton tape. That will really be more like the surface of a flexible PC board anyway. I have the soldering iron set to like 630 degrees here, Fahrenheit. Probably could go a bit lower, but with the Kapton tape backing it, it's not melting too bad, and it's tinning quite nicely. The temperature sensor I'm using is an MCP9701 in an SOT23 package. I decided to put the FFC strip on a piece of aluminum to solder on the chip. Just tacking it to hold it in place. I'll put some flux on the connections. And then solder the IC leads. This will be a bit less mass than a Flex PC board, but I don't think that will make much difference. I'll do the same thing at the other end, except attaching 3 wires instead of the temperature sensor, and then clean off the flux. This was probably the most difficult part of the entire operation. These are 30 gauge wires, and getting 2 of the wires into a single pin was hard. I won't do that again. I'll make a splice down the line somewhere to split the wire into 2. But if this test works, this will be the cable I use to attach to the final temperature sensor boards. Too much work put into it not to use it. I'm cleaning the heatsink base where the thermal tape is going to go. I'm using a large piece of the tape, probably a mistake, but I'm going to give it a try. Then I'll put the sensor in place. pressing it a bit into the tape. I'm going to use a bit of gasket material to press down on the sensor. Probably not needed, but it makes me feel better. Hopefully, being gasket material, it will have a pretty high thermal resistance. Then I'll put it all back together and then it's off to the software. The primary core of this MCU has one ADC core shared between all the analog inputs, which is fine. I'm only going to read a temperature sensor every 2 milliseconds. That will give me 1 millisecond for sampling and 1 millisecond for conversion. And right now I think I'm only going to be using 3 external temperature sensors and maybe the MCU internal sensor. I'll do a bit of figuring to see what kind of clocks I need for the ADC. Then a bit of code to read the sensors. So now I have the fans controlled by both the power and the temperature. At this time in testing, it's the temperature of the one MOSFET, as there is just one test sensor. The code is set to turn on the fans when the ADC value reads 1250. That should be about 88 degrees Fahrenheit. Why not 90 degrees? 1250 is a nice round number, and I want it low enough that I don't have to wait too long before the fans kick on. Now I have the thermocouple right up next to the MOSFET, so I would expect it to read a little higher than the mounted temperature sensor. But these are not the A version, so they have a typical accuracy of plus or minus 2 degrees C. Well now, fan came on right at 88 degrees, so I would say the temperature sensor is reading a little bit on the high side, but by far close enough to get the job done. I think that's going to work out just fine. Now I need to have some flex PC boards made, as I don't really think using the modified FFC is a good long-term solution. I have the MCP 9701 sensors in both the SOT23 and SC70 cases, so I'm going to put both on the PC board. So I laid it out with 2 SEC70 sensor parts and 2 SOT23 parts on the one board. Should be able to cut them apart quite easily with just a razor knife. The reason to go with the Flex PC board is of course to reduce the mass and thickness of the board the sensor is on. I'm going to order these from Osh Park, so I should end up with 6 SOT23 sensor boards and 6 SC70s. Now Osh Park's Flex PC boards are pretty thick for a Flex PC board, but I've got a couple of SMD parts on the board that can't take much flexing, so the thicker Flex should work out great. So I'll get them ordered. The Flex takes longer than the regular FR4, so I'll get back to this when the boards arrive. I kinda expect 2 to 3 weeks, but these days, who knows. Okay, the Flex PC boards have arrived. A little under 3 weeks, right in line with what I was expecting. I'll cut the boards into the sensor strips. They cut quite easily. Yes, I think those are going to work out very well. I'll just save the SC70 strips, as I'm going to be using the SOT23 ones. 2 resistors, 2 capacitors, and 2 MCP 9701s. I'm not going to break out the solder paste for this. I'll put a bit of extra flux on, and then put some solder on one pad for each part. Tack the parts in place, and then solder them on. I'll go ahead and tin the pads for the wire leads. I'll clean the flux off, as well as making sure the backside of the board is very clean for the thermal tape to stick to. I do want to be very careful not to bend the boards where the resistor and capacitor are. Those parts just won't take bending stresses very well. I've decided I'm going to do the thermal tape in 2 parts for each sensor board. I do want to try and keep my fingers off of the sticky tape. I'll press it down a little bit. Again, I don't want to put much stress where the resistor and capacitor are. Now the second piece is just for the area under the temperature sensor. Probably not necessary, but the more I thought about it, the more I thought it might give a bit better temperature reading. What it's going to be adhered to is probably either nickel-plated aluminum or copper, so it really may not make any difference. And after attaching the wires, they should be ready to go. But before I install them on the heat sinks, I do want to double check and make sure they are working. So I'll hook up 3.3 volts to the boards to check them out. I've let the sensors set so they should be about the same temperature. So about a 26 millivolt difference between them. That's well within tolerance. They are reading less than a 2 degree centigrade difference. That's close enough, probably don't even need any kind of calibration. I'll throw a bit of hot air on them and make sure they are working. Both seem to be working well, cooling off quite fast. That's very good. I think they are going to have a pretty good response time. I'm going to put some of this UV sorter mask on the exposed wire leads, help to support the wires a bit more. Also, I'm going to put a little bit on the resistor and capacitor, but I'm not going to put any on the MCP 9701. I'll put it in the sunlight for a bit, and then we'll be ready to install them. I'm going to clean off all the heatsink compound. That way I can mark exactly where I want the sensor. And I have to have the surface completely clean for the thermal tape to stick. I'll use some masking tape to mark where the MOSFET sets. Then I'll cut the edge of the tape where I want the sensor to align at. Have my marks to help me position the sensor. The edge of the tape represents the edge of the MOSFET. So the sensor will be positioned around the lower third of the MOSFET case. Then stick it in place. I'll press it down a bit, and that should be a good spot. Then I'll do the same with the other heatsink. I think the thermal tape will hold it in place, but I'm still going to use the gasket material to push on the sensor board just in case. I'm putting a bit of Kapton tape over where the gasket will push against the sensor board, as I have no idea what the electrical properties of the gasket are. If the sensor board were to come loose and one of the terminals touched the heatsink, it could very easily destroy the MCU, and maybe even more. It's just not worth the risk. I do have wires everywhere at this point, but everything unplugs except the blue wire I have spliced that goes to the MOSFET power boards. That's the modification that supplies a -5 volts to the MOSFET boards. I've decided to live with them like this for the time being. These temperature sensors are the last hardware I'm installing, till I get the software somewhat under control. I'll get everything plugged back up. All my little 1 1/4 millimeter click connectors are all 4-pin. The advantage of that is I only needed to order 10 of one part number. The disadvantage, I've got to think extra hard to make sure I plug into the correct header. Though I did make the 3.3 volt and ground the same pin number on each of them, so if I do plug into the wrong one, it won't damage anything. It just won't work. Okay. Time to see if after pulling everything apart it still works. I'll get it hooked up and set to 29 watts, so after a bit the fan should come on. There we go. Took a minute or so, but everything still seems to be working, so I'm happy with that. One final temperature test. I haven't done any test with the cover on, and I do need to try that. I'm not sure how much the cover is going to restrict airflow. I've got a thermocouple on each of the heat sinks, so this should give me an idea of how well the fans are doing. Everything is at room temperature at the start, and room temp is about 83 degrees Fahrenheit. I'll move to centigrade to show the heatsink temperature. So I'm going to start at 29 watts, just to watch and see if the fans start after a minute or so. Okay, fans started as expected. I'm going to move to a 100-watt load now. Fans barely moving, maybe just a bit over the lowest speed. Looks like at 100 watts, temperature stabilized at around 38 degrees C, and I can't hear the fans running. Can barely feel slightly warm air coming out, so very little air movement at this point. Moving up to 200 watts, if I remember correctly, this should kick the fans up a bit. I should be able to easily feel the air movement at this level. Temperature seems to have stabilized around 41 degrees C. Still can't really hear the fans, which is nice. Now going to move up to 300 watts. Much easier now to feel the air movement, and it's feeling much warmer. So seems to have stabilized 3 degrees higher, now at 44 degrees C. Can hear the fans a tiny bit, but still overall they're pretty quiet. Going to 400 watts now. The bench area seems to be feeling a bit warmer, and I don't think the fans are at max, but they are very close to it. Now I'm at over 50 degrees C. Fans are running at max now, I'm pretty sure. And that last 100 watts moved the temperature up about 6 degrees C. So at 400 watts, I think the heat sinks are starting to struggle a bit. Setting it to 500 watts now. That's about all the power supply will do without overheating. And I think I will probably be able to say that about my electronic load as well. Room temperature around the bench is much warmer now. I say much warmer, probably more like 2 or 3 degrees Fahrenheit. I can just feel the warm air coming out of the load, and it's a lot of warm air. Temperature seems to have stabilized around the 56-57 degrees C mark. Probably will creep up a bit as the air around the load gets warmer. It's staying under the maximum of 60 degrees, so I'm happy with that. I think a 600 watt load will have to be in short burst. It wouldn't take long at 600 watts for the MOSFET junction temperature to probably exceed the 150 degrees centigrade maximum. And I don't really want to replace the fans, these get loud enough. All I need out of the load is 500 watts. I was just going for 600 to give me some leadway. I'm sure it will do 600 for a short bit, I'm confident of that. I would say as long as the room temperature is below 100 degrees, Fahrenheit of course, it should run at 500 watts just fine. So I should be good to go. I should have checked this sooner. Bench area temperature is about 86 degrees Fahrenheit. It feels a lot better at the bench than it did a minute ago. So the load raised the area temperature by a few degrees. So definitely this thing is going to be much better to use in the wintertime than in the middle of summer. But I'm happy with the test. I don't see where the cover restricted the airflow much at all. For the most part, the hardware is complete. I will make new MOSFET power modules that are designed for the negative supply rail, but not till I'm happy with the software, and that may take a bit. It will work for what I need it for right now, but the user interface is really rough, and I would like to improve that, at least a little bit. As for the constant voltage mode, I'm still not sure how to handle that. The only thing I can think of is to have a different averaging time periods. A very slow one for like 60 or 120 cycle ripple, and a much faster one for switching power supply ripple. But that's going to be a software problem, and I may not get to that till I run across a need to use the constant voltage mode. And I still have some resistor values to tweak in a couple of areas. So this is not the last of the electronic load project, but it may be a while before I get the software presentable. Thank you for watching.